This video will continue our discussion of curvature and try to relate it to a curve in space. Okay, so far we've answered the question of curvature. This answers how fast a curve turns, right? Decides how quick is that turn, how fast does it turn. The next thing we're going to talk about is called a principal unit normal vector. It determines the direction in which the curve turns. So curvature tells me how fast it turns. The normal vector tells me, or principal unit normal vector tells me the direction it turns. So specifically, the magnitude of ds dt is the curvature. Okay, so that was on the past sections, the past videos, so we determined that. So here's the big question that we're going to ask now to clear up and lead into this next thing. What about the direction of my unit tangent vector? So remember, in space, if we look down at this picture, this normal tangent unit vector points in the direction that the curve is going. So I want you to, I want to run through what that dt ds will look like and what direction it points in. So let's start with our tangent vector. So this is going to answer this question if you want to do that. We know that the norm, or the magnitude of the tangent unit vector, it's a unit vector, is 1, which means it's constant. So that means if I take that t and I take the derivative with respect to t, or s, it really doesn't matter here, of t, and I'm going to dot it with t. Okay, well, this was t dotted with t, and then you take the square root, right? That's what the magnitude is. So if the square root of t dot t is 1, then t dot t is also 1, which means it's a constant, which means I take the derivative of the constant, and I get a 0. Okay, so, but where does that lead us after this? All right, well, if I do the product rule, I got t prime times t, and then I also have its product rule, so I get t times t prime. Equals 0. All right, well, this is just two of those. T prime times t, which equals 0. Well, this implies that t prime and t equals 0, which tells me if the dot product between two vectors, then they are orthogonal. So what that means is, since we're working with the tangent unit vector, t and t dt, ds, t doesn't really matter, are orthogonal. We'll leave it there. Okay, are orthogonal. But if we're only concerned with the direction, right? This is the pointing in which way it's going to turn. We don't care about the length or the magnitude. We only care about the direction. So we apply this idea and use a unit vector. So what this means is, this is the way we needed a way to describe which direction that the space in the curve in 3 space is going to go, which direction, and this will be based on this normal vector. The reason this makes sense is, if you think about tangent, tangent is the derivative, unit vector, right? It's just a derivative. Derivative is velocity, and then if I take the derivative of t, which is r prime, that's r double prime, which gets me acceleration. So if this vector points in this way, that means my graph, my curve is accelerating in that direction. So that is where it's going to curve, in which way. So by definition, we're going to use this vector so we made the definition we have, and we're going to use this as our working definition. This is how I think about it. So n of t is t prime t over the magnitude of t with respect to t. We could have done s, but that's that arc length. It's just kind of harder to work with. So our working definition is that by what we are making happen, the normal vector is practically acceleration as a unit vector. But it's going to tell me which direction the curve is going to go. So take a look. Also to point out, if it's the derivative of a unit vector, we get a unit vector. So we have unit vector there, and then also we already talked about this, that they should be orthogonal. So take a look at this curve in 2 space. At this point here, the tangent vector tells me which way to go, and then the normal is going to tell me how to turn. So notice this is going to the right there, and it curves. And this one's going to the left, it curves back that way. So the normal's always going to be showing where the curve is going to turn, where the curvature is, really, is what it is. It's pointing in the direction of the curvature. Okay. Properties of this unit normal vector, it's an orthogonal with t, so we get this like orthogonal vector flying through space, where t is always pointing at where it's going, and n is like it's where it's going to be turning. So like you could think of an airplane. T is where the airplane points, n is the wing that points in the direction of like turning. So it's like the wing is pointing down. Right, so we get that, since the orthogonal dot product is 0 at all points. And then also, this was the big thing, that the unit normal vector points to the inside of the curve in the direction that the curve is turning. So that helps us out quite a bit. I could see this application maybe happening in video games, right? Stuff like that. We're going to have these vectors describing where your character is moving given direction.